All right, hello, I'm Landon Schlungen, and today we're going to continue on with our basic JavaScript. And last time we ended off with understanding undefined value returned from a function, so that's where we're going to begin today. Let's get started. Understanding undefined value returned from a function. In this challenge, they want us to write a function called add5, and then they want us to add 5 to the sum variable, so that should work. Yep. Assignment with a return value. Here they want us to make a variable called processed and then set it equal to this function. So process arg that has an argument of 7 passed into it. And now when I console log processed, I get 2, which would be 7 plus 3 divided by 5. So yeah, run that. Stand in line. So here's another FreeCodeCamp challenge. We want to make a function called next in line that takes in an array and an item. We'll do var removed equals r, so the array dot shift, so that takes off the first one, and then we'll do array dot push item, and then we'll return the removed item. That should work. See, we popped off the 1, and then afterwards it has 6 at the end. Run that. I think we need to put r dot push above r dot shift, and then maybe it'll work. Yep. Understanding Boolean values. Here they just want us to change this false to a true. Booleans are only true or false. That's the only 2 values it can be. It's an on-off switch. If you put quotes around it, then it's not a Boolean anymore, then it's a string, but right here it's a Boolean. Use conditional logic with if statements. Here they want us to have an if statement and then pass in was that true for the if statement. And then if it was true, we want to return yes, that was true. And then otherwise, if it's not true, then we want to return no, that was false. So if was that true is true, then it'll return this. But then if it's false, then it'll return this. But then if it's true, you might think that it'll return both of these, but once you call return, then it exits the function and it's over. So it will only return this statement if it's true. So let's try that. Comparison with the equality operator. Here, double equals is the equality operator that checks if one value is equal to the other value. So here we want to check if value is equal to 12. And then there's also like strictly equal, which is triple equal sign. So that has to be like the right type as well. But this could be a string and it would still work. And then also if this was just one equal sign, then it would actually set val to 12 and it wouldn't work. So it has to be a double equal sign. So run that. Yep. Comparison with the strict equality operator, kind of like the last one, except triple equals and then 7. So it'll check if it's strictly the number 7, not the string 7, just the number 7. Yep. Practice comparing different values. So right now the function is comparing 10 and the string 10, and right now they are equal. But if we do strictly equal, then it'll actually be not equal. There we go. Comparison with the inequality operator. So inequality is denoted with an exclamation mark and an equal sign. And then we're going to check if it's not equal to 99. So basically, whenever you see the exclamation mark before an equal sign, you can just say not equal, and then it'll make more sense. Yep. Comparison with the strict inequality operator. So it's kind of like the last one, except we put 2 equal signs after it. We see if it's strictly not equal to 17. Yep. Comparison with the greater than operator. Here they want us to check if val is greater than 100 or if val is over 10. So we do that with the greater than sign, and that works. Comparison with the greater than or equal to operator. Here we'll use greater than or equal to 20, and then greater than or equal to 10, and that should work. Yep. Comparison with the less than operator. So we'll do less than 25 and val less than 55 and check that. Yep. Comparison with the less than or equal to operator. Same as last time. Less than or equal to 12. Less than or equal to 24. Try it. Yep. Comparisons with the logical and operator. Here they want us to get rid of the second if statement and then instead do if val is greater than 50, greater than or equal to 50, and val is less than. No, we want to do val if val is less than or equal to 50 and val is greater than or equal to 25, then return yes. So yeah, it's saying exactly what I just said. If value is less than 50 and val is greater than 25, then return yes. On that. Yep. Comparisons with the logical or operator. Here they want us to get rid of one of these if statements and do if value is less than 10 or value is greater than 20, then return outside. So it's saying like if value is outside of 10 and 20 is what it's saying. So if it's 9, then it'll return outside. If it's 21, it'll return outside. Introducing else statements. So else is what will happen when the condition is false. So they want us to combine this into an if-else statement. And then basically if value is not greater than 5, then it'll say result equals 5 or smaller. And try that. Introducing else if statements. So here we'll do else if value is less than 5. It's basically another if statement chained on, and then we'll add an else at the end. Else ifs always go in the middle, else is always at the end, ifs are always at the beginning. And yeah, we'll move this in here, and we'll move this in here, and then delete this and run it. Logical order in if-else statements matter. Right here, if value was 5, then it would say less than 10. Or if it was 3, it would still say less than 10, even though it would be more accurate if it would said less than 5. So what they want us to do here is change this around to be less than 5, then it would be less than 5. And then value less than 10, then it'll be less than 10. So that way, if value is 3, then it says less than 5, but then if value is 7, then it says less than 10, and it's much more accurate that way. So let's see if that works. Chaining if-else statements. Here they want us to do a bunch of if-else statements to return different types of text. So I'll do that quick here. So here, if number is less than 5, return tiny. If number is less than 10, return small. If number is less than 15, return medium. If number is less than 20, return large. And then otherwise, if it's none of those, return huge. Let's try that. Yep. Golf code. So here they just want us to make code that tells the score of a golf game using if-else statements. I'll do that quick here. All right, here I got it done. If strokes equals 1, that's obviously a hole in 1. If strokes are less than par minus 2, then it's an eagle. If strokes equals par minus 1, then it's a birdie. Then if strokes equals par, it's a par. If strokes equals par plus 1, it's a bogey. If strokes equal par plus 2, then it's double bogey. Otherwise, if you get higher than that, then just go home, obviously. Over here, they had a nice little cheat sheet for me, and let's try it out. Yep, it works. Selecting from many options with switch statements. So switch statements are a lot like if-else statements, except they're a little bit more confusing. So try not to use them. Switch takes in value, and it'll have a case of 1. So if it's 1, then what we want to do is set answer equal to alpha, and then break. And then if case is 2, so if value equals 2, then we want answer to equal beta, and then break. And then if case is 3, we want to set answer equal to gamma, then break. And then if case equals 4, so if value equals 4, then answer equals delta, and then break. And I think that should work. Yep. Adding a default option in switch statements. So there's this default option that you can put at the end. And basically, if it doesn't match any of the previous cases, then it'll just default and do whatever this one is. So for this, they want us to set up a default for another switch statement. So I'll do that quick here. All right, there we go. If it's A, then print apple, or if it's A, then answer equals apple. If B, answer equals bird. If C, then it's cat. If it doesn't match A, B, or C, then it's just stuff. So try that. Yep. Multiple identical options in switch statements. So here, as the example provides, you can have case 1, 2, and 3, and then if it's 1, 2, or 3, then it'll do result equals 1, 2, or 3. Otherwise, if it's 4, then it'll just do 4 alone. So for this challenge, they want us to do 1 through 3 is low, 4 through 6 is mid, and 7 through 9 is high. So I'll do that quick. So there we go. Case 1 through 3 is low, case 4 through 6 is mid, case 7 through 9 is high, and try it. And also make sure they're capitalized. Yep. Replacing if-else chains with switch. So here they want us to replace this if-else statement with switch cases. So switch the value. Case where value equals Bob, we want answer to equal Marley. Case where answer equals 42, we want answer to equal the answer. Case where value equals 1, we want answer to equal there is no number 1. Case where value equals 99, answer is going to equal missed me much. Missed me by this much. Case where value equals 7, answer is equal to 8, 9. And then delete your if-else chain statement and try it out. Yep. Returning Boolean values from functions. So in this case, we're checking if A is less than B, but we can just do return A is less than B because that'll return a Boolean anyways. And that's way simpler than what we had there before. Return early pattern for functions. Here they want us to check if A or B are less than 0. If A or B are less than 0, they want us to return undefined, probably so that it doesn't crash when it does this. Yep. Counting cards, another FreeCodeCamp challenge. I'll do it and then I'll show you when I'm done. Alright, so here I think I got it. So if the card is less than or equal to 6, then we want the count to plus equals 1. Also, if the card equals 10, or if it's Jack, Queen, King, or Ace, then we want the count to decrement by 1. And then at the end, if count is less than or equal to 0, then we want to hold. Otherwise, we want to bet. And we also want to display the count with that return value. So let's try this out. And yeah, it works. Cool. All right, build JavaScript objects. So right here, my dog is an object denoted by these brackets. And then we want to do whatever this is saying. We want to have my dog have a name. I'll say Foo. And then you'll have legs of 4. You'll have tails of 1. And friends of an array of Jody, Leo, and Cool. So yeah, so now my dog is holding a bunch of this information. So let's try this out. Accessing object properties with dot notation. So the way we access object properties is by grabbing the my object and then calling dot on it, and then it'll let us access prop 1 and prop 2. So here they want us to take hat value and make it the test object dot hat. So now hat value will equal baseball, or ball cap I mean, and then we'll take test object dot shirt for the shirt value, and now shirt value equals jersey. Run that. Yep. So now we'll access object properties with bracket notation. This is very useful when these keys have spaces in them, or like even just dashes like that, because dot notation wouldn't work otherwise. So here we'll do a bracket and then we'll do the string and entree. So now it'll grab hamburger off of that. And then for the drink value, we'll do the drink. Run that. Accessing object properties with variables. Here we just want to set player number to 16. And then we want to grab test object player number. So here we're grabbing test object where it's 16 because player number equals 16. So we're grabbing Montana. Run that. Yep. Updating object properties. Here we'll grab mydog.name and we'll set it equal to happycoder. And what this does is it sets this name part to, instead of coder, it'll set it to happycoder. And that's all it does. It grabs name. If I would have legs here, then it would grab this one and set it to that. But I grab name with the dot notation instead of bracket notation. I could do that too, but I preferred to use dot notation. It's just cleaner in my opinion. Add new properties to a JavaScript object. Here we can add a new property to it by just doing my dog dot, and then you can add bark in by doing dot bark equals wolf or something, wolf. So now it'll basically add on here a bark of wolf, even though it's not there right now. It will once this code runs. Delete properties from a JavaScript object. Here we can use the delete keyword, and we can delete tails dot, or my dog dot tails off of my dog. So now it won't even have this property. It'll just get deleted. Run that. Using objects for lookups. Here they want us to turn the switch case statement into just a simple object, and then it'll basically have the same functionality as the switch case statement. So I'll do that quick here. So there we go. I believe I successfully completed it. So when we do Charlie here, Charlie will be the value here now, and then we'll do lookup on Charlie, and then Charlie is right here, and it'll grab Chicago from there, and then return the result of Chicago. So I did that for all of them, and it should work now. Run that. Yep. Testing objects for properties. Here they want us to change this to be object.hasOwnProperty, and then we'll check it if it has check prop. So it has own properties, its own little function in vanilla JavaScript, and it basically just checks if this object has the property of whatever check prop is, like when it's passed in as when the function is called. So try that. Okay, I actually have to put it into an if-else statement, and then if it has this property, then we want to return that property. Otherwise, we want to return not found. Let's try that. Yep, there we go. All right, manipulating complex objects. Here, all they want us to do is make another album. So I'll just copy and paste this down, and I'll just get rid of this gold true, and we'll try that out. Yep. Accessing nested objects. Here they want us to grab whatever's in the glove box, so they want us to grab maps. And the way we do that is first we grab the object, which is my storage, and then we go into it by using dot, and then we grab car, and then we go inside of car by doing dot inside, and then we go inside by doing inside dot, and then we'll grab the glove box. We'll actually not use dot because glove box has a space in it, so we'll do bracket notation for this one, and that should successfully get the maps for us doing this chunk of code here. It'll grab maps, and we'll run that. Yep. Accessing nested arrays. Here they want us to try and grab pine, and the way we do that is by first grabbing the array, my plants, and then accessing the second one, which would be index of 1, and then we'll grab the object of type. Well, actually we'll grab list, so dot list, and then we'll grab the second one in there as well. So we're going into this array, we're grabbing this object, and then we're doing dot list on this object. So that grabs the list here, which is this, and then we're grabbing the first index of that, which is pine, and that'll grab us pine. And run that. Yep. So record collection. This is another FreeCodeCamp small little challenge in here, and we have to make this function follow all of these rules. So I'll do this, and then I'll show you how to do it after I'm done. All right, this might work. This took me about 10 minutes or so. So if prop isn't tracks and value is not equal to an empty string, then grab the album, so the object of, right here it's grabbing 5439, which would be this one. So it's grabbing that one, and then it would set the prop of artist equal to the value of ABBA. So that's what that would do. If prop equals tracks and object does not have tracks as a property, then set the object's prop to that value as an array. If prop equals tracks and value does not equal an empty string, then push the value onto the tracks of that album. And then if value is an empty string, then delete that object's property. So I'll try this out. I'm not sure if it's going to work or not, but let's see. And it doesn't work. It passes some of the tests, but it looks like it fails a couple, so I'll fix these quick. Okay, I'm pretty sure all I had to do was get rid of this double equal sign. I have to use assignment and not comparison. I don't know why I had double equals there, but yeah, now it's just an equal sign. Let's see if it works now. Yep, there we go. Sweet. I think this is a good stopping point after that hard one before it. So next time we're gonna probably go through the rest of the JavaScript challenges, and yeah, I'll see you next time when that comes through. So see ya.